Hello grade 8s, this is Mr. Miller and welcome to lesson 9.3 on linear relationships. So first of all we want to consider the linear equation y equals 3x minus 1. We want to make a table of values using x equals -2, -1, 0, 1, and 2. You can see that all of the x values are already filled in for us. We just need to figure out what the y values are. So to calculate those, we're going to use this equation, the y equals 3x minus 1, and we are going to replace the x with -2 first. So we do 3 times -2 minus 1. Then for the next one we do 3 times -1 minus 1. And the next one we do 3 times 0 minus 1. Then we do 3 times 1 minus 1. And 3 times 2 minus 1. And let's see what we get when we calculate this each time. Just going to move over to my calculator now. And do 3 times -2, take away 1, and that gives me -7. Okay, so now again I'm going to do 3 times -1, take away 1, that gives me -4, and 3 times 0, take away 1, and that's -1. And maybe by this point you're starting to figure out that each time we're increasing y by 3 while x is going up by 1. So adding 3 to the -1 gives you 2, and adding 3 to the 2 gives you 5. I mean, you can double check that. 3 times 2 is 6, minus 1 is 5. Yeah, that does work. So now from here we want to plot these points on the grid. And so let me just first of all label this is the y-axis, this is the x-axis. And now we can put our points on. So the first point we've got is -2, -7. So that's 2 left and down 7. That's right there. And the next point we've got is -1, -4. So it's 1 left and down 4. And the next point we've got is at 0, -1. And then we've got 1, 2. And the next point we've got is at 2, 5. Now I'd like to have this extend all the way across the grid. So what I can do is I can extend this pattern of going up 3, right 1, up 3, right 1, to get a few more points. That way I should be able to make this look pretty accurate. So let me switch to my tool for drawing straight lines here, and I'm going to do this with arrows on the ends just to show that this relationship can continue on in both directions. So going from here to there, making sure I'm going through all those points. And I can pull it out here so that you can see it going through all those points and beyond. So there's nothing that indicates what exactly the x and y are standing for. No reason why x couldn't be these in between, like x equal to 0.5 or anything like that. So I think it's okay here to connect the dots and to extend it beyond, because again, no restrictions on what x and y are supposed to be. So this relationship between x and y, for all we know, could extend all the way to infinity. And so now we would like to use the equation to calculate y when x is equal to 4. So using the equation, y would be equal to, sorry, that's supposed to be a y there, 3 times 4 minus 1. So 12 take away 1 is equal to 11. And now the next question, just zoom out so I can see the question and also still see the graph, it says for the point x comma -10, what is the value of x? So we have a y coordinate of -10, which you can see right here. So if you go along at a y value of -10, this is the point we're looking at, and it has an x coordinate of -3. So now you can see from the graph how I determine that. It's x equals -3. So now moving along, taking a look at number 2 here, it says that the graph below represents part of the linear relation y equals x over -2. We want to use the graph to find y when x is equal to -1. So when x is equal to -1, we don't have a point there. So maybe what would be useful is to connect all these points together with a nice straight line. And, whoops, didn't want another line there. Just want to extend this one. So now it's going all the way across the grid. All right, next. When x is equal to -1, so here is where x is equal to -1, and I can go from here up and make a mark, and then go across and look at what is this y value. And it looks like y is equal to 0.5 there. Now, using the equation to get y when x is equal to 16, we can go y equals x equals 16 divided by -2. That would give you -8. And now another one of these points really give the point x comma 3.5. We want to estimate the value of x from the graph. So for a y value of 3.5, so here's 1, 2, 3, and here would be 3.5. So if I go across here to the graph, and it just looks like it goes right to there, and that's an x coordinate of -2, -4, -6, -7. So now you can see both how we're using the equation and we're using the graph in that example. And let's take a look at the back side of this page. Next thing we want to do is we want to graph the ordered pairs from the table of values. And so here's what we're going to do. I'm going to set up, draw the x-axis right along the bottom of this grid, and I'm going to set up the y-axis to go up here. There we go. And so let me just label these as our y and our x axes. And it might be a good idea to indicate the size that we're looking at here. So this is 1, 2, 3, 4, 5, 6, 7, 8. So this is the scale that I'm going to use on this axis. -1, -2, -3, -4, -5, and so on. Okay, so now vertically, 1, 2, 3, 4. This goes up to 10 here, and it goes up to 20. So one thing that you do want to make sure you do before you start doing your graph is make sure that your grid has enough room to fit the points that you want to have on here. So x needs to go at least up to 4, and y needs to go at least up to 16. So you can see I've got room for that here. Okay, now let's actually get these points on there. Graphing the ordered pairs, we've got 0, 0 is one of the points, 1, 1 is the next point, 2, 4 is right here. Next point is 3, 9. Next point is 4, 16. And so there we go. Now the next question is asking, is this a linear relationship? And we want to use two different ways to explain our answer. So one of the ways that we explain this is by looking at the change in y over change in x. So the change in y is 1, and then it's 3, and then it's 5, and then it's 7, and the change in x is 1, and it's still 1, and it's still 1, and it's still 1. And what you notice is that the change in y over change in x is first of all 1 over 1, then it's 3 over 1, and then it's 5 over 1, and then it's 7 over 1. Are these things equal? No, they're not equal. So to answer the question, it's no, because the change in y over the change in x is not a constant. Also, the points are not all on the same straight line. And if we tried to do that, it just wouldn't work out. So if we connected this point to the next one, you'd see that it just doesn't go through any of the other points. So it doesn't work out that way. If you went from the second point on, notice that that kind of a sloped line doesn't match up with anything else. You could try to sort of do a line of best fit here, but you'll notice that no, there's no way to really get going through all of, no matter how you angle this, you're not going to be able to go through all the points with one straight line. So we'll just take that off of there. And that's it. So, I mean, there definitely is a relationship that exists here between y and x, and if you weren't sure about it, this is y equals x squared, right? 0 times itself, 1 times itself, 2 times itself, 3 times itself, 4 times itself. But it's not linear. Linear relationships will never have an x squared or a square root or dividing by x, anything like that. It will always have x just to the power of 1. So the most complicated that we might get is something like, y equals 3x minus 2, or 3/5 x minus 2.5. You can have that, but you can't have any different exponents like squared or cubed or anything like that. As soon as you do that, then you don't have a linear relationship anymore. And you'll also know that they're not linear relationships because when you graph the points, you'll see they're not all on the same straight line. Anywho, so that concludes our lesson for 9.3. Thanks for watching and have a great day.